Well, thank you. I'm Heng Chye Kiang, and together with Prof Sun Lingyun from Zhejiang University, representing on behalf of our team from National University of Singapore, Zhejiang University, SUTD, and SIT. The title of our proposal is Sustainable Cities in the Anthropocene through Nature-Based Engineering and Data-Driven Integrative Urban Planning. Can you see the next slide? Okay, sorry. Okay, I'll spend a few minutes talking about the global situation now very quickly. As you all know, the global situation isn't very pretty right now. There's COP26, and human activities are increasingly influencing negatively the Earth climate through all our different activities. And these activities also affect our ecosystem in various ways. Overpopulation, overconsumption, plastic production, draining of streams, etc., greenhouse emissions. And all this I just captured in the last month, and the so IPCC 2021 say that the Earth temperature will go up by 1.4 to 4.4 degrees Celsius depending on what we do. Now, carbon emission. On the one hand, you see temperatures going up. On the other hand, extreme rainfalls in Italy. This is a new European record, 740 mm in 12 hours. And across the continent, you have permafrost thawing, threatening homes, but also threatening to release even more carbon into the air and increasing the vicious cycle. And on the other hand, we also have growing cities and rapid urbanization. Right now, by 2050, about 58% of the world's population will be living in cities, increased from 56% just a year ago. And all these growing cities and urbanization will feed increased industrialization, commercialization, which in turn consume more energy produced by fossil fuels and will in turn exacerbate our climate change. So in this particular slide, where you follow my cursor, there's three activities up here, or these three items here from the city geometry, which has to do with layout and planning at various scales, right? Contributes to warming quite substantially. So city geometry, as I said, which has to do with urban planning and design, and even at a smaller scale, building design, contributes substantially to this warming. Heat and human activities contributes also to this. All these are actually taken from IPCC's report. And heat retaining properties of buildings and roads, later on we'll look at UHI, also contributes to it. On the other hand, water and vegetation mitigate all these effects. So linking these two, city planning, city making, or urbanization is a primary cause, one of the primary causes of environmental impact, given its massive demand for natural resources, and subsequently its development, operation, and maintenance. So our hypothesis is that if city making is intricately linked to our Anthropocene future, then judiciously planned cities and townships informed by scientific and empirical evidence will yield the most effective sustainable cities. So I emphasize here, it must be informed by scientific and empirical evidence. So well, let's come to this Anthropocene future of ours. It's since about year 2000. This we have coined this term that the human activities is the main driving force behind the Earth's geological and climate change. So, how can we design cities that can deal with Anthropocene, such as mitigating the impacts of carbon crisis, reversing climate change, and even restoring our environment? In short, how can we live in synergy with nature? I like to show you this video that was on YouTube just a few days ago, with this T-Rex attending the UN session, and he says, "It's now or never. Don't choose extinction." And indeed, I think it is really important that we, as human species, choose to build our cities sustainably, adopting a comprehensive, systematic, and integrated approach to urban planning based on scientific evidence, and adopting this enduring principles of sustainability. Just very recently, we have this SG Green Plan 30, Singapore Green Plan 2030, based on the 5 pillars and enabled by green government and green citizenry. But cities are complex. If a car is complex, with some 30,000 parts, cities are even more complex. In our research on urban resilience, we came across this diagram here, which shows the number of overlapping systems, and as a proxy here also for urban sustainability, from socio-ecological, social, and then socio-technical, so on and so forth. So, to solve this very complex problems, we have assembled a team from NUS, JOTA, SUTD, SIT, to work on this different aspects of sustainability, addressing them with our respective strengths, and also creating test beds both in Singapore and in Hangzhou, home base of JOTA. Our research program basically aims to transform urban planning with new evidence-based knowledge derived from scientific, engineering, technological, data science, and social behavior research through design-led applied research for translational outcomes. It is divided into 3 main thrusts, or composed of 3 main thrusts. The thrust 1 is understanding the Anthropocene. Thrust 2, urban planning in the Anthropocene, and all these supported by the 3rd thrust, which is a horizontal, of urban diagnostics. So, to go into slightly more detail, you'll see that in the 1st thrust, we have nature-based strategies, and together with that, mitigating ambient temperature. And in the 2nd thrust, where urban planning is concerned, we have both land-based planning and coastal urban planning. And as I mentioned earlier on, all this supported by the urban diagnostic horizontal. So I will very quickly go over the 3 thrusts, and the 1st thrust, which is on understanding the impact and the effects of Anthropocene. We all know that nature is very important to us, that the nature-based solutions on land would help to adapt and mitigate climate change, provide us with better air quality, reduce flooding risks, cooler air, mitigate noise, etc., etc. I don't need to go into all these details. The chart here shows the different benefits of different kinds of land, from ranging from agricultural land to, of course, forests. Our research questions basically are these for this nature-based component, and these are really focusing on Singapore, especially important because we are really small, and given our community size, our actions have real consequences. There are a lot of trade-offs in development, so the key questions here are: where are the green spaces and coastal habitats that we must defend at all costs? And I think this is a foremost important question of foremost importance. And where are the necessary ecological buffers and corridors that we need to protect or restore? What are other green and blue spaces left? Where are they located? And what are their marginal values? What more can we do by leveraging a city's natural capital to strengthen our ecological, climate, and social economic resilience? Where are the development alternatives? Because as I said earlier on, whenever we look at development, it comes with trade-offs and sometimes necessitate the removal of existing nature. And what kind of ecological approaches can we adopt to new green and blue spaces to help mitigate the loss of nature? So following these key questions, this is how we intend to answer them. We need to map, we need to model the different values of the different urban greens and blue spaces in terms of the multiple ecosystem services and the core benefits they provide, ranging from carbon storage and sequestration to mitigating rising ambient temperature, biodiversity conservation, coastal protection, and ensuring human physical and mental well-being. I will come to some of this in greater detail later. We also need to model different scenarios of retaining versus converting existing green spaces and coastal habitats to minimize trade-offs with other competing land users involved in development, and at the same time maximizing the benefits they deliver to society. And how do we translate all these that we have learned into planning? You know, when I showed the car earlier on, the car with its 30,000 parts, it needs engineers, designers, all these to put it together to optimize its performance. However, for a city, very often we do not have that. We have engineers and scientists understanding the city, but planners and designers not necessarily involved in this collaboration with the engineers and planners and scientists, planners, engineers, and scientists in order to optimize our cities during the planning stage. So it is important here to translate all this insight into urban planning and for coastal defense. Let me move quickly now to link up with this nature-based solutions. You can see here that for NUS, we have planned, the president has planned to plant 100,000 trees by 2030 or 10,000 trees annually. This is also part of the nature-based solutions. I'm showing here the expertise that my colleagues comes with. For example, in the same team is working now on the mitigating the urban heat island effect and ambient temperature. This team of colleagues comprising Prof Heng Chye Kiang and Yuan Chao and their researchers have done massive work on the modeling and mitigation of ambient heat. In this case, on the campus, NUS campus. Here again, ambient temperature increase by anthropogenic heat emission from residential buildings. You can see here with and without wind speed, high wind speed. So with higher wind speed of 7.4, you actually get a lower rise in temperature, whereas with 1.1 meter per second wind speed or very low wind speed, the temperature increase is substantial. At the same time, you see here the urban heat island circulation effect, and with this, what I call a chimney effect, the heat plume, in this case over Newton, air would be drawn in from the surroundings, and all this pushing up. If we look at this on plan and imagine that if this is Singapore even, you can imagine that all this wind can be coming in from the sea onto the island, or from the western catchment into this heat plume. But the physics of it is actually less clear than we think we understand, because if we do not understand this properly, it may lead to pollutions being trapped, particles being pollution being trapped within the heat canyons, etc. So this is an important area where I think my colleagues are working very hard on, and it is with this understanding that when we begin to plan cities, we can plan them optimally to avoid all these adverse effects. I'm quickly showing you the work that they have done on Marina South to mitigate the ambient temperature there, in conjunction with the modeling of CFD, the wind map, and together with the combining the temperature map and the wind map, we get one of the thermal sensation loads. So I will very quickly move from here to this overall map of Singapore, thermal showing the heat map in short. You can see that on this heat map, this area represented by PLAB is an important area right now. It provides a kind of green lung as opposed to the surrounding urbanized areas. We have, on the whole, the eastern sector is warmer than the western sector here. But with the moving of Paya Lebar Airport, how we urbanize this area, how we develop this area then becomes very important, because if we're not careful, we may replicate the kind of conditions in the adjacent new towns, adjacent urbanized areas, and have a whole patch of red here. Similarly, in the GSW or global, the Greater Southern Waterfront, you can see that there are a lot of red here, and how in the redevelopment of the Greater Southern Waterfront can we plan in such a way that it will mitigate this redness here, this heat island here, so that the entire area can be a little bit more green and blue. Okay, I'll move to so here, urban planning with new evidence-based knowledge derived from scientific, engineering, technological, data science, social, behavioral research through design-led applied research for translational outcomes becomes especially important. Let me just show this drawing again from my colleagues working on the Research Thrust 1. They have quickly produced this map in the context of another research that shows the wind path and the importance of retaining this wind path and openings when we urbanize and develop PLAB. So how we then develop this becomes very important. In this particular aspect, is only the wind that is concerned, but certainly, as I've shown earlier on, there are many other aspects that we have to address in conjunction with planning and the understanding of Research Trust Fund. In this other section, I will show you some of the work that my colleagues and I have worked on at different scales. So in this case, coming back to this heat map here, PLAB, I've led my students to work on this, on how we can plan this area. One of the studio exercises, looking at it more as a system. Or this Greater Southern Waterfront, again, through design research. But what is important to know is that at different scales, whether it's building scale from site to neighborhood to a city, sub-region, the region and national scale, different strategies are adopted. And but of course, planning and urban design is an integrated, comprehensive way of problem solving. And at different scales, different kinds of problems will present themselves and different solutions and strategies adopted. So let us look at the kind of work that my colleagues and I have been working on from building scale. In this case, the SDE4 building is a very good example of how we solve it at a building scale. But also at a medium scale here, usually associated with urban design. And earlier on, when I showed the example here of Marina South here, you can see that over here there's another attempt to, after understanding all those physics, how we can, through our planning and design, achieve better outcomes. So different scenarios, different outcomes. Similarly, at another location, we have also worked this out at using all this optimization through understanding of modeling and simulation. So I'm going to show you a couple of projects that we've done to underscore the importance of nature and engineering-based data-driven planning. In this case, we have selected 100 examples of different types of urban form, and using several factors like sky view, sky exposure, solar radiance, or solar irradiation rather, and their relationship with various geometrical variables, arrive at different relationships of the geometrical variables with those performance such as sky view, sky exposure, and solar irradiance. And finally came out with this multidimensional optimization Pareto ranking. And what I want to emphasize here is this, that for the same, in this horizontal axis here, 3.4 plot ratio or FAR, you can have various performance from very high and good to very, very low. And similarly, for the same performance here, you can find that some of the buildings or compounds will achieve very high plot ratio, and others are low. So, which means that planning and design really matters when it comes, and the understanding of the science behind it really matters. So it's not just sticking your finger in the wind. And even when it comes to coastal protection and all that, here again is what my PhD student, together with my colleague from civil engineering, have produced. That is to show that the array, how we plan the buildings along the shore, the way you array, the way you plan it, does affect the impact and mitigate the effect of coastal surge. So I won't go into detail. And finally, I would like to show this, that in my own professional work as a consultant, in 2013, this plan was completed. Instead of we have proposed 7 different kinds of shorelines to a island nation well, I wouldn't say where, and proposed a shoreline that both protects this island, but at the same time offers a reservoir, allows for floodwater retention, the entire system of rainwater harvesting feeds this reservoir, and it was awarded a Global Cityscape Award in 2018. And for Singapore, how do we then reclaim these islands, for example, in the context of Singapore, becomes even more important. So this is where my colleagues from SIT has done a lot of work on land reclamation using lumpy fill and have achieved outcomes that are laudable and been awarded several awards, including the Minister of National Development Award in 2015. Just to spend one more minute maybe on this before I pass on to my colleague, is that to do all this, we do need to be able to assess how effective our work is. So we've done this piece of work over the years, supported by MND, to set up a assessment framework. We benchmark some 90 case studies around the world, set up this particular framework, identified some 850 indicators, which we subsequently cascade down to 158 indicators in this 13 themes and 55 dimensions. Themes such as land, water, food, with all the different indicators and the metrics, and the historical evolution in Singapore's case in comparison with other cities. All these will be part and parcel of the future diagnostic tool, as well as the assessment within each of the trusts to ascertain that we have we're doing better than we currently are. So in the next component, I'll leave it to my colleague from Zeta to tell you about the Research Trust 3. Thank you.
Thank you. Thank you, Prof Heng. I'm Sun Lingyun from Zhejiang University. We believe the ultimate challenge to the science of sustainable cities lies in formulating a comprehensive and systematic approach for planning, design, implementation, management, and governance. A promising solution is to provide a dynamic and adaptable urban diagnostic tool to aid in testing different scenarios to arrive at optimized solutions. Next page, please. So when we talk about the topic about sustainable cities, our team share an understanding of the new world, which is human cyber physical world. The world around us is experiencing changes never seen before. In human society, technologies such as AI, IoT, social networks, and big data have extended our familiar physical existence, combining it with their new virtual dimensions. Thus, this world has changed into an HCP world, which is overlapped by human society, cyberspace, and the physical one. So next page. So our research team is from different colleges, include College of Civil Engineering and Architecture, School of Public Affairs, College of Environmental and Resource Sciences, etc. The team is working together as a multidisciplinary team with the objective to build a sustainable world. So these slides show our research layout. Basically, the research is organized into 3 supporting building blocks: the physical world, the cyberspace, and human society. So in the physical world there, we use IoT and AIoT devices smart materials, sensors, and cloud and edge computing platforms to collect big data. In the digital space layer, we apply the data from the physical world to develop decision models, simulation models, digital models, and prediction engines. In the human society layer, we use the models in the digital space to explore urban data, analyze urban crowd flow, assess transport, simulate architectures, etc. As an integration of the three layers, we are providing solutions to the city operating systems. This is not a one-way structure. The operating system is also providing service, knowledge, and intelligence to the three layers, which can empower the whole system. Next. Let me show you several examples conducted by our colleagues in Zhejiang University. This one is design-based scenario, which is HCP representation. In this project, we provided a 3D scene presentation in real time, which uses multi-channel cameras to monitor urban areas. The system can effectively and intuitively express the overall situation. It's very convenient for users to have a bird's-eye view of the overall situation. Next one. The second example is the data-driven transport assessment. There are so many traffic factors, such as road, infrastructure, traffic flow, vehicle speed, etc., influence the transport assessment. In this project, we present a data-driven solution by leveraging a visual analysis system to evaluate real traffic situations based on taxi trajectory data. We provide a novel route-based query model for analysts to interactively conduct evaluation tasks. Next one. This example is human mobility modeling. Human mobility refers to the movement of human beings in space and time. This project presents a graph-based approach for structuring crowd mobility transition based on data from mobile phones in the context of social behavior. Next. The fourth example is spatial temporal urban data analytics. Urban data is massive, heterogeneous, and spatial temporal, posing a substantial challenge for visualization and analysis. We designed a visual analyzer for urban data to support urban data visualization, querying, and exploration. Next one. The fifth example is human movement citywide study. To understand mobility and transportation patterns, we need to study human movement citywide. We designed a set of visualization techniques to illustrate the dynamic evolution of the flow over the networks. The main functions include flow volume analysis, flow link analysis, and analysis of social related and flows. Next one. Another example is visual diagnostics in smart factories. Visual analytics play a very key role in Industry 4.0 as modern machines and assembly line generate large amount of data. So effective visual exploration techniques are needed for troubleshooting, process optimization, and decision-making. This system supports both real-time tracking of the assembly line performance and historical data exploration to identify inefficiencies and form hypotheses about the causes and effects. Next one. Now our team in Zhejiang University is collaborating with Alibaba in the world-renowned project of City Brain. So we are creating a data ecosystem from the perspective of government, industry, and internet. The City Brain can optimize public transportation based on comprehensive data analysis. This picture shows the real-time transport perception and population mobility. Next. So this area is still under developing. We just launched Zhejiang University Alibaba Digital Transportation Innovation Application Center this year, and we launched a ZGU virtual lab for computational digital transport last year. We are also working with the NUS and the SUTD teams, trying to establish a very comprehensive, systematic, and integrated approach to urban planning, adhering principles of sustainability. Thank you. Prof Heng.
Thank you. So to come back to this last slide, so this is a 4-university collaboration, uniting the strength of NUS, Zhejiang University, SUTD, and SIT. Thank you.
Okay, thank you very much, Prof Heng and Prof Sun. In the interest of time, is there anyone who would like to raise one question before we move on to the next presentation? Anyone from the attendees? Oh, Dr. Lin?
I'll give up my slot to anybody else who has a more urgent question. But since nobody else asked, let me just ask my question to Chye Kiang and Prof Sun. I mean, the span of the ideas you propose is very wide. I think you mentioned that, and there has been and there are lots of ongoing projects in different parts of what you have been talking about. How do you see yourself putting together a program proposal that would not appear to be starting from scratch, but drawing upon all the other work that has already been done in the ecosystem? Thank you.
Well, thanks, Dr. Lim. I will attempt to answer part of this question, and I'm sure Prof Sun will have other ideas. So first of all, we're conscious that there are many efforts that have been conducted and are ongoing in these areas, both in nature-based solution as well as in the area of ambient heat. So certainly the team, proposed team, will first of all learn from all these projects and not reinvent the wheel, but there will be gaps. There will be a lot of other things in these two areas that my colleagues whose research has spent together maybe hundreds of years will be able to build on what has been done and fill those relevant gaps and indeed advance even further, in particularly to the benefit of urban planning. So how it can be translated into more effective plans. Earlier on, I've shown the section that shows this heat plume. In fact, in my own discussion with my colleagues, even though a lot of work has been done in this, in the case of Singapore, it is really specific. Is the heat plume, this urban island effect here, strong enough to make sea breeze and land breeze behave differently, such that and is that one of the reasons why at night we practically do not have wind, right? So on and so forth. And if that's the case, how do we then plan our city differently to improve in all respects all this different downstream effect of urban heat island. Okay, I stop here. I don't know whether Prof Sun have other supplementary comments. And of course, the diagnostic tool is super important in this respect.
Okay. I think according to our understanding, our ultimate goal in this project is to achieve sustainability through urban planning. That's only one goal, and it's how we link everything together. However, we are doing something quite different because we are using the algorithm, big data platform, science ways. And so now what we are talking about urban planning is totally different. We are not only planning the future city, we can also provide short-term or immediate responses to the public or to the governance. So that's how we put everything together and to achieve our goal. Thank you.
Thank you, Prof Heng and Prof Sun. We have one last question from Jen. The program proposes to develop many simulators and models. How would they be integrated onto a common platform to systematically address the larger problem of city design?
Prof Sun, do you want to answer this question?
Okay, I try my best. Okay, I think what we are planning to build is a 3-level system. The first one is, as I mentioned, is short-term or immediate responses. The second layer is medium-term governance and service. The third one is long-term urban planning. So basically, we are using these three layers to put everything together to achieve the whole system. So, Prof Heng?
No, thank you. I have nothing further to add.
Okay, I think that wraps up about the Q&A for your presentation. Thank you very much, Prof Heng and Prof Sun, for your presentation.